Yo, 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 what's going on? How's everybody today? How's the stream? Do I sound alright? Music okay? Everything's all good? What's everyone up to? Having a good week so far? Wednesday where I'm at. Should be Wednesday in America now in the Pacific. Busy watching that Tesla stock, yo. Wow. I am making some money tonight. Just that little bit closer to getting that 3D printer. Just that little bit closer. One step at a time. So, what are we going to do today? Well, we're going to go through all this reference material I've collected. All of these photos, PDFs, balsa plans, just photos that I've taken of the actual plane, by watching Mike's videos on YouTube and then just taking screenshots of everything I can possibly think of. Like, I mean, here I got this shot when he was working underneath the horizontal stabilizer. Just so I can get like an image of how this tail ends, how the top surface of it looks, how it connects to the vertical stabilizer, how it pivots on the elevator, all the bits and pieces. Shots of this tail gear with this dampener and stuff, how the tail gear assembly works. I got some fun shots of when he was like working on this CAD stuff. This is gonna be super useful. Super useful. This whole piece here on the front is an extension that he added to the plane. This is crazy. Where's the picture of it? Where they installed the extensions. Yeah. They just bolted on a piece on the front of the wing. Nuts. It's just nuts, brah. Shots of when they did the 3D scans of the plane. Because this is a nice orthographic shot of the aircraft, so I can get this angle, which is really important to modeling it. Stuff like this. Yeah, so I've got lots of awesome stuff. Got the EASA documentation, European Union Aviation Safety Agency. This goes through all the Wilgers from the 104 Wilger 80, Wilger 32s, the 2000s, all the Wilgers, all the information. This is a big document. Lots of stuff. Most of it's going to be useless to me, but there's going to be interesting stuff in it. For instance, let me just move to a random spot and pick something. Load factors, not so important, but we do have this information. So this is important information here. Wingspan, 11.28 meters. So we can say 11 meters to be safe if we just chop off the tips, because I'm trying to measure from the center of the plane to the end of the chord. This is important for when I'm doing the designs for it. I don't need the tips. I can design those after and then make sure that they're inside of a certain size. But it doesn't matter anyways, because of course he decides, no, I don't want wingtips that are, that small. So he made his own really awesome ones. Where's the picture of it? So he made these. These are standard, but then he cut stuff out, added these spacers on it because he increased the front of the wing, and he's also increased the trailing edge. So he's had to modify this, and then goes and builds an entire new light assembly on it, which was really cool. That's going to be fun to model. Modeling this shape is going to be loads of fun. There you go, Ruby. Nice of you to join me. How have you been? You doing all right since you got back out from the hospital? I saw that on your Twitter. What have you been up to? What else we got? We got some really nice shots for when he made. He makes this wing tip, right? This modified wing tip, and then he's like, you know what? I don't have enough fuel in the plane because I want to make this trip. I want to go a little bit further, so I need more fuel. So he goes ahead and he makes a new one that's the same thing, but it's a little bit longer, and there's a fuel tank, an extra fuel tank inside here, and it's just like, dude, that's awesome. Am I going to make the engines? Do you mean the engine singular? There's one of them. Here's a picture of the plane. So I'm going to use an electric motor. The plan so far, this may change, this is early days, we're still working out the design constraints. I've got this Turnigy motor. This is the Typhoon 500. This is a motor out of a model helicopter. So this is, you put this on a gearing ratio. Now I want to make a adjustable pitch propeller. So I'm going to need planetary gears to change the gear ratio for this motor anyways, because it's a very high torque motor, to an assembly that allows me to adjust the prop. So I'll have a servo that can change the prop, so I can set this at a set RPM, and then I can adjust my thrust by increasing or decreasing the prop, which also allows me then to have reverse thrust, so I can do the same sort of flight performances that the real plane can do. That's the plan. I've got all sorts of bits and pieces here. Like here's the rotor stock, the rotor head assembly of a helicopter, model helicopter. So yeah, this is gonna be fun. But right now, what I'm trying to work out is how big I want to make this thing, and that's a lot of fun. Working out how big you're gonna make something. And I've got Inventor open, and I've grabbed some of these shitty balsa plans. Oh, not shitty. This is the best one out of the few that I've collected. Where was the plain good one? This one. Balsa plan. This was a good PDF document. Nice, crisp, clean lines. Good internal structure. I can get good angle geometry off of this, work out the angles and stuff. But again, like these are designs for a model aircraft. So these angles might not necessarily be the exact same as the real aircraft. So, and it's so hard to find actual documentation of the real aircraft to pull, dimensions off of. And I don't need all of this, information about the wing spars and how to cut the balsa for the spars. I do, however, need things like how big do I need to make the ailerons and the flaps and stuff like that. And these are useful for getting the cross sections for the fuselage for making the model geometry. So that should be good. Well, this was a good set of plans, but it's not the best one I found. The best one I found, and I labeled it as very good, is this one. These ones, got all the, this is the flap. What do they call that? Not strut, knuckle, hinge point. What do they call them? I forgot what they're called. Give me the name, please. Brain, come on, hello. Give me the name. There's a thing of them in here somewhere. Here. Oh, they just call them hinge. Hinge extensions, control horns. That's it, control horns. So, control horns are the ones that you attach to the flap or the aileron, and then the hinge is the one that the aileron of the hinge is attached to, and the control horn is what you put your lever angle on. Your lever to, so. This was a really good set of designs, really good set of plans, and I can zoom right in on this to get nice, faithful. This is a vector drawing, so I can get really faithful images that I can take screenshots of. Yeah, it's Hinge. I thought they had a proper name. There's a proper name for them. I forget. So yeah, this I will mostly be using this. It has wire landing gear. Like, I don't know why the main gear is made out of a bent piece of, you know, music wire, yeah. 0.063 wire, not useful. So the landing gear is going to be the biggest design challenge, because I'm going to have to reinforce them with carbon fiber rods. So I'm going to have to design cavities inside of the thing for the resin printing to slide those rods in there. But then the actual suspension mechanism is going to be quite difficult, because he made quite a robust system, but when you get down to this small scale, it's going to be trickier and trickier to put like the axles through. I'm going to have to get either carbon fiber axles or metal axles, or get brass bushings or something to actually stiffen up some of those designs. Where is it here? So this is the knuckle assembly for the suspension hinge, and he's got a big strut that he sticks in the back that comes off this piece that he stuck off the side here. So I would have like a carbon fiber rod. Let's zoom in on this. I'd have a carbon fiber rod that would run through this up to the fuselage, and then like I could probably get away with then drilling a hole from the other side here and putting another rod through this way, or the vice versa, drilling a hole, and then having that drill go through the first rod that I put in, and then I can epoxy that all together. And then this here, I don't know, like the connection between this big rod that goes to the fuselage and then this axle that has to go in here. Maybe this rod is going to go through a rod that I first put through here. So I put one rod in here first. Let's make it bigger. So we put the first rod through here. Then we drill the hole through that one and a hole through here to line up with the hole that's already in there for that one. And then I put one from here in here and drill through it here, and then put one through here. So that'll create a nice stiff frame there. And then do the final drill for this one for the axle. This piece I don't think needs to be very strong. I'm going to just put some small carbon rods through it like this and drill for the axle as well. Because I'm definitely going to need a rod through here, because the wheel sits on the outside here. So that's going to be interesting. So it all depends, like how big I want to make the design is going to determine how much strength and how much structure and how I have to design each of these smaller components. It's all well and good at saying I'm going to have a plane with a 2.2 meter wingspan, but then you have to go look at what's your smallest component that is actually functional, that you need to work. Will that withstand the job it has to do at that small scale with the materials and the manufacturing process you're going to use? And that's what we're going to work out today. So I've got this open. Now, I started with, okay, based on how big my resin printer is going to be, determines how big of an object I can print at one go. So if I want to make the wings in a reasonable amount of time with a reasonable size to get, you know, the structure for the carbon fiber spar, all the hinges for the flaps and ailerons, the leading slat on the front, then it needs to be a certain thickness, and that's going to determine the length of the cord. So I'm going to go with 250 mils for the length of the cord. So from the front edge of the wing to the trailing edge of the wing with a flat, about 250 mil, maybe a bit more. This is just because this is missing the actual flap here. The flap. So 250 plus. So where's my tape measure? So if I get that out and I measure out 250 mil, that's going to be a nice That's gonna be a nice fat wing. Right. From here to here. Right. That's a nice fat wing. So there's a lot that I can fit in that space, and I can measure on the. Now that I've got that measurement, I then get the drawings. I'll put them in Inventor on the images, the image planes, and I scale them to that measurement. And then I can start pulling off other measurements. So then I go pull off the wingspan from the center of the plane, and it's around 1,100 millimeters. So that's a 1.1 meter wingspan either side, which is a decent. This is going to be a 2.2 meter plane. let's just show you how big 2.2 meters is. Right, this is a decent sized room. See that back corner over there? That's about 3 meters away. There's 1 meter. There's 2 meters, 2.2 meters. I'm touching the door handles on the other side of the room over there. So that's a decent size. That's a decent size wing. As she says, it's pretty big. So that's gonna be lots of fun. And I can print that. So I can print the wings standing up inside the resin printer that way. We hope. That's gonna be fun. So what else do we need to work out? Now I need to work out like the small components, as I was saying, the landing gear and that. And I've got a book that I've been writing when I spent the whole day yesterday watching his videos for the build series for the Draco, and writing down every little bit of information I could. So I've got a whole page of writing all sorts of fun details. And the big tires that he stuck on this thing. Where's the music run off to? Stupid music. I have to switch back to it to get it to start playing. Where are we? Right. So, he's got 35-inch tires on the front. So, based on the fact that I know that I'm going to have a wingspan of 2.2 meters, and the real aircraft is 11 meters in wingspan, that's a ratio of 1:5. So it's a 1/5 scale aircraft. So 35-inch wheels. Now I'm going to have to get the calculator out because there's going to be some fractions in here. 35. No, there's not. It's divided by 5 and it's 35, so there must be a multiple of 5 in there somewhere. Not minus 5. What am I doing? I can't even use a calculator. Go to bed. No, not times by 5. Jesus. Welcome to Chaos' stream, where he fails to even use a calculator. 7. So that's 7 inches. I love Inventor because I can come in and go, right, I want a circle, and I want to make it 7, and then I just write inch. And it will make a 177 mil circle, which is apparently 7 inches. Stupid imperial measurements. Right. Let's stick this to roundabout where that tire is. Other fun information. I worked out the new cowling that he made, because he built an entirely new cowling for the front because he put this new motor in. Where's a photo of it with the motor? So the motor that he put in it, this engine, is a Pratt & Whitney PT6A-28. And that is one schmexy turbine engine. So schmexy, right? But the original motor that was in here was a Lycoming flathead. And that only came to like here. So the front end of the plane used to be like this, right? But now it's going all the way out to here. So he had to make a new cowling for this. So I took photos of all of that work that he did. Got some photos of the underside of it, these NACA scoops that he's built in it. Those are really cool. I love NACA scoops. All carbon fiber. Oh, carbon fiber is so sexy. So yeah, there's the new one that he made. And he made this by taking the front end of his other turbine plane, and he took the front third of that, and he took the back third of the original cowling off the front of the aircraft, and he took molds off, he took carbon fiber replicas off them, put them next to each other, and then blended the two together to make this new cowling. So it's got a bit of the old cowling, a bit of a new cowling from his other plane. It's very cool. I took photos of everything I could. Where is it? Where is it? Where is this very particular image that I'm looking for? Did I take a screenshot of it? I'm pretty sure I did. I don't think I did. How irresponsible of me. Do I just have a photo of the side of the plane somewhere? Oh, you guys can't even see what I've been... Oh, what a doofus. Forgot to change the camera. So, yeah. Okay, so yeah. He built... I've been sitting here talking, you guys have been watching me talk, and you have no idea what I was pointing at. He built a new front end for the plane. A new cowling. So, in one of the shots in one of the videos, he was doing the cut line for the aircraft. Did I give it a name? A new cowling underside. No. I'm sure I took a photo of it. I must have taken a photo of it. He was cutting for the NACA scoop. It was during this episode. Was it this episode or another episode? It must have been this episode because he's painted it in this one and it's already cut in half. Oh, this is so annoying. YouTube, save me. Let's go to his channel, playlists, Draco build, view full playlist, and I think it was this one. Let's mute it. Get a name for the video? Trailing link, no. Carbon fiber cowling completion, more carbon fiber, take a better autopilot, tailwheel designs, enlarging rudder and tail system, turbine pressure carbon fiber. One off cowling, that one. Un momento. Nope, not that one. I'm getting close. Getting closer. No, he's already split it in that one. Wow. How useless am I? More carbon fiber. I think this is the episode. This is the episode? Please be the episode. Yes, this episode. Right. here. He did this, right? This is how clever I am, okay? This is how clever I am. I'm real clever. He draws his line to cut, so he needs to split the cowling top and bottom, right? So that when you do maintenance aircraft, you pull the top cowling off or the bottom cowling off, whichever, right? It can't be done, you can't take it off in one, so it has to be split. So he's splitting it. So he's drawn his line, and he's doing it real clever because he marked every 6 inches and then like a 1/4 of an inch gap, and then another 6 inch, and then a 1/4 inch, all the way down the length of it. And he was taking his Dremel and cutting along the 6 inches and then leaving that little tab and then cutting the next 6 inches. So that when he goes on the inside of it, he can lay up the carbon fiber along that line and wax the one side and so it sticks to the bottom half and then doesn't stick to the top half. So he's got this new like tab, this edge that runs the inside of the hull. You can see it. He just explains it. I don't think he actually does it. He does it in the next episode. But yeah, so he cuts these tabs all the way along. And now I watched carefully for the shot where he moves out of the way and you can see all of the lines. Like there's a section where you can see the back half and you can count to where this black spot is here. And then count the rest of them. So I counted each one of those marks and then counted up all of the 1/4 inch like little gaps and worked it out at being around 81.25 inches is the length of this cowling that he's put on the front. Now this is a very rough estimate, but based on those lines, I can get pretty close with those numbers. And looking at photos and that and comparing the size of the tires, I mean, I've got images like, where is it? I'm sure I am missing some photos here. I must have overwritten a bunch because I'm sure I've taken screenshots of this. So I don't know. I'm going to take a screenshot of it now. Save. 68. I don't know. Save. So I can compare now because I've got a rough estimate and I know what size those tires are. I can work out the size of that engine. Shots like this one. It's taken, the camera is very far away, so it's a very long shot, which means there's very little perspective shift on the image. Everything that's in the foreground is very similar in size comparison to the background. There's very little perspective shrinkage, and I can come in and go, right, from here to here. Screw it, where's my tape measure? If I know that the tires are 35 inches and I measure it on the screen at 105 millimeters, and then I measure up here to that is at about 165. That's not right. There's a bit of an angular perspective shift. So let me measure from the middle of the tire up to the top of the tire, which is a vertical angle. There should be very little perspective shift on that. And we get 50. So double that, it's 100. So not 100 and, what did I get first? 105? Yeah, but 105, 110. Right, so if we go, so 100, and then the length of this is 165. So bring out that calculator again, good old calculator. 165 divided by 100 is obviously going to be, why do I keep hitting the times button? 165 divided by 100 gives us 16.4 65. What am I doing? I don't know. Help? So 65. So if I take 30, so let's take 35, and we divide that by 100, is obviously going to be 0.35. So 0.35 times by 165, 57.5. And then we times by 35 again, gives us 221 millimeters. Right? I'm sure I've done this completely wrong, but the answer will be pretty close anyway. So 221 millimeters in inches is 79.566. So I'm pretty damn close with my 81. And this has got a bit of a lean to it, like the plane is pointing away, so that measurement will be a little bit shorter because of the angle that the camera is looking at it from. Woo, go me. So yes, I will run with the 81 inches. It is pretty damn fucking close. And we will carry on with that. So, coming back to here, let us put in this doodad, which is going to be our firewall. Now see, this is why I don't like these balsa plans, because they draw it funny compared to the real aircraft. If I go and get another image, let's grab that orthographic 3D scan that they created of the plane. Let's chuck a... Nope. Other one. I don't know why it flips around in some of the views. You put the vertical constraint for a horizontal constraint. Let's move you out of the way. So, where is a line on here that we can absolutely guarantee we can use as a reference piece? I think it might be the tip of, oh, excuse me, windshield to the start of the door frame. So the door frame in this image is along this line here, because in here they've removed the door. So this is why I don't want to use the balsa plans directly. You look at the radius of this door here versus the radius that they've got on this balsa plan, completely wrong. And that's why I'm only using them for like very basic measurements. But at the end of the day, I'm going to be using these pictures that I grabbed off YouTube from his videos, because they're going to give me far better dimensions when it comes to certain angles and radiuses and stuff on things. I mean, even just the angle on that windshield is different. No, it's about the same. It's pretty damn close. So what other measurement can we use that'll, from the gear here through to that point there under the wing? Let us draw that on here. point to there. Right, we will use that as sort of a reference point. Now also, when this photo was taken, the aircraft had a bit of a lean on it. You can see the underbody here has an angle. So I might grab that and delete this, just so I can scoot you to be horizontal like so. Maybe that was a bit too far. That looks better. So now I'm trying to line this up to the balsa plan, which is no good. Yeah, it seems straight. So it looks like that angle on the balsa plan for the firewall is actually pretty close. So let me measure that angle that's in there and see if it's a round number, which is pretty close to. If it were 110, let's bugger this off. Bugger that off. Let's build the aircraft off of this point. So that's going to be my central reference geometry right there. I really should do it off the CG, which will make life easier, but no, we're not doing that. So we'll stick you there, and then we'll grab this point and we'll stick you there. So 110 isn't quite right, so let's try 105. And 105 looks heaps better. Shift you out of the way. Let me nail you to the middle of the map. So I can work with stuff. Stick you back in there. Right. So 105 is a lot closer. And in fact, I'm going to call it at 105. That looks damn straight. Yeah, it was built at Reno Airport. It was crashed at It died in Utah too. It died in Reno. How you going, man? Good to have you here. I get carried away and I keep forgetting to check chat and stuff. So just I don't know. Chat louder, all caps. Hey. Sweet. So we have that angle. That's good. Fine, dandy. Happy days. Oh, happy days. Now, what are the pictures that we have here that we can use to get some information off this plane? I still haven't got any word back. I've sent him a message on his Instagram account. I have sent him an email on the email that's provided on his YouTube channel. I'm not sure how else to get in touch with him. He does not have a Twitch account from the looks of it, or if he does, it's his personal, private, home life sort of thing. This image. Now we must remember when we are pulling geometry off of this thing. So we've decided we're going to make this our common reference point for all geometry in the plane, or as much of it as we can. We must not pull pull reference off of this bottom edge of the cowling here, because the cowling sits about 5 inches lower than the keel of the plane. Now I want to get this angle here in relation to this angle here. So this is a pretty damn good photo to do that with. Edit, edit, flip it, just save it. Sweet. Close. And then also, I have images that we took when he was working on the aircraft. So this is another good one, because this is with the where he was building the fuel tanks. He created his own fuel tanks to hang off the landing gear. So he had all the aerodynamic cowlings taken off of it, and you can see all the extra struts and stuff that's in it. So this one gets closer to the bottom line of the aircraft, and we can see the one in the background, so we can compare geometry off that. That's a good one. I've got another one here. This one is taken in line with the shock, looking at the aircraft at an angle. But it lets me get the geometry for like the angle of other stuff. There is a bar that runs through the middle here. I'm pretty sure I have a photo of a front facing of the cat. This one here, that'll get me. Would you say that's about 90 degrees? I'd say it's about 100, maybe 95. Between 95 and 100 degrees, that squat. But I want to find out how far forward the rake angle on it going forwards. I think this is going to be our best bet, is this one that we flipped. Ooh, actually, this one's pretty damn good, and it's already in the right direction. And it gives us a nice clean point there for that line going down, and the one for there. It's pretty straight. Seems to be a bit of an upsweep here on the base of this cowling, so we need to remember that. But I can see both of them, and we've got these here. These are straight on with the aircraft. Yeah, we will use this one. So, excuse me. Let's drag another image in here. This is going to get messy. This is just a random part sketch, so I haven't saved anything particular. Where is that image? This one. They always open up like that. I wonder why. Now, there is an option in Sketch to go into the images, properties, and set transparency. And just set it to like a gray, and that'll give it a half transparent. Or not. be a bit bigger. And a bit bigger still. Bit smaller. We'll go with that. We've got to line that up there. Put one on there. Keep it pretty parallel through the strut. Comes off right to the outside, so let's move it right to the outside there. Let's not include the cables that are there. And what else? I want to grab one off the other side for the other strut. So let's just set that like that. Sweet. And then I'll come in and grab a dimension between these two. So we've got about 1.5 degrees difference, and then I can grab this one off of here, and would you look at that, it's 39.5. So if we split the difference and say it is 40-degree angle, that looks pretty damn close. So let's delete that. I'll grab my sketchbook and we'll start putting in some of these things. New page. And we'll just do a rough sketch of the aircraft quite easily by opening this up. Central line. Right, so we said that angle there is 105. The gear angle (40° off the vertical). I want the lower firewall angle. Yeah, no, we'll go with the upper. Go with 50, and then we adjust this. Let's chuck you out of the way. Chuck off the line off the bottom here, make sure it is perfectly horizontal. So we can line the image up nicely. And yeah, 50's not quite enough. So let's not go off this one. I bet you if we go off this one, it'll be nice and simple. Let's lower that to 20°. Too much. 23 it is. Does that jive? I think that jives. That jives. Just about. We drag you down like that. And that jives. Okay. I like that. I like it a lot. So this angle (25). Where are my gel pens? Go on. There we go. So, going by the scene angles, the scene doodads. I don't want a glitter pen. I hate glitter pens. Rulerini. Cool, and we've got blue for the Z-axis. Red for everything else. You better not be a glitter pen. You're a glitter pen. Oh, why do I have so many glitter pens? God damn. Gear, firewall, a black one. Let's write this all down. (40° for the gear angle. God damn, glitter in black? Why is there glitter in my black pen? (25). 105. No, we're not going 25, we said 23. 23°. Sweet. All right, angle attack on the wings. This is going to be trickier. I can't use this image. I don't want to use this image. This is pointless for me. But we can write some other stuff down, so we are indeed going to go with a wingspan, or yeah, wingspan of 2.2 meters. (2,200 millimeters). And now, based on that photo that I used for, which is in here, I still need to move it over. View, planes, navigation plane, save pictures. This one here. This cut line, when it goes all the way to the back, it only goes to so when he drew this cut line on here, he drew it from the center of the circle here. Let's make that a bit smaller. So from the center of the circle there, and he drew it perfectly in line with the draft of the plane, which doesn't come up to this point that we're using as our reference point here. So I went up a bit on this side and like that, and I went down a bit on this side. I had it cut out for the gear apparently. But the measurement I have is for this length of this line. So this cut line, I measured it out for, what was it again? (81.25 inches). So let's say that's another 4 inches, and say round up 85 inches for the length from the reference point to the front. We can all be in agreement on that. That sounds like a fair assessment to me. It would be lovely if I could get in touch with Mike and say, hey Mike, how long was the new cowling front end from this point to the front face before the spinner? Give us a number. It's all right. I'll take metric. I'll take your imperial numbers. I'll convert them for you. It's okay. Don't worry about that. Just give me the numbers. I want the hard data. I'm sure he's got a file on his computer or somewhere with like the exact wingspan, the exact weight, area, like because he did all the calculations and everything for everything, so he's got all those numbers. And if only I could just go, hey Mike, hey buddy, please have dimensions, thank you. Can has. So let's grab another color here. Let's go with the orange one. I'm gonna just take my ruler And get that orange one started. Because if we look at this image and we follow the draft, this comes to about a quarter of the way up the circle. That needs to be a bit taller. And a bit longer. This drawing on this page is not to scale at all. Right. So if I go from this point to there, I can write in there. Now we need a number. So we have to now convert this because I'm going to put this as the model scale numbers on this page. So if we're going with 85 in the total length of the cowling from that corner there where it meets up with the fuselage to the front face before the spinner, we still got to work out what this diameter on that front face is as well. Ooh. Calculator, thank you. We go 85 divided by 5 is 17 inches if it's to scale. So 17 inches in real measurements. Oh, I know this one. I know this one. This one is easy. We already have this. Because it's right here. Right? This one was 7 inches. Okay, never mind. Never mind. Let's just draw a line from here to there, and we just type 7 inches. Not 7. You doofus. Where's the 1? You need a 1 in there. You are the 1. So that is 431 millimeters, which is pretty big. That's almost not going to fit in 3D printer. Almost not going to fit in 3D printer. I'm going to have to print it like on a diagonal, and they'll be printing top and half bottoms separately. So let us write that down. And if we drag this line now over to that point to there, to this here. Now this image, we haven't got to the correct scale, but it is pretty close based on some arbitrary MacGuffins. So I'm happy with going with 431. And in fact, let's just make it a nice round 430 because, hey, I like round numbers. They're easy to remember. $430 millimeters, fantastic. And if I take my pencil and let's just draw a better looking representation of the wing. Like such. What color? We just had orange. Running out of colors. There's only so many primary colors. It's got glitter in it. Purple. Let's go purple. There's no glitter in that. Come on, start. These haven't been used in a while. I don't think these are brand new. I haven't touched these. I haven't used these. So I need to get them all started first. A bit of a squiggle to get them going. Nice purple wing. Good at that undersweep. Lovely. And let's use this purplish color to draw the line across for the length of the cord. This unfortunately has glitter in it, so I'm not happy about that. But what can you do? And we said we're going to go with a 250mm cord. Cord spelled like choir with a ch, because that makes total sense. Hey, where is my handy dandy compass? That is unfortunately decapitated. There is no lead in it. Lovely. Let's just drag a little bit out there. Is there enough behind it? Maybe? Possibly? Let's see if we can pinch that down. When I get my new 3D printer, I am going to be... One of the little side projects I'm going to do is going to make a mechanical pencil compass. So I'm going to pull the guts out of a mechanical pencil, measure them all up for the housing and whatnot, and design a mechanical compass that's got a... Yeah. So you don't have to go and take the collet chuck and put a new piece of lead in there. I can just go down the side of it and a piece of lead sticks out. Right. Let us draw just a basic pitch circle, a big one. So that I can write in here for the tire, what did we say? 177 diameter, circle with a dash through it. Now, I've already previously calculated the prop diameter because the prop on, you should really be like doing something like this so you guys can see what I'm doing. So the prop on the bush plane, there's a 102-inch prop on it. So if you work that out to a 1/5 scale, that becomes a 20-inch prop. And we don't have to convert that because all prop sizes are in inches. But if you want me to convert it, a 20-inch prop is... There's no inches on here, so I'm going to have to convert it. A 20-inch prop is 508 millimeters. Woo! So, my pen, the prop, DIA for diameter is 20 inch or 508. Now, because I am going to make a variable pitch prop, like an actually mechanically working variable pitch prop, so I can have a fixed RPM motor, because it is a fixed RPM. This motor is out of a helicopter, RC electric helicopters, and they like to run at a fixed RPM. They have very high torque and whatnot, and they're very good. And I'll make a planetary gearbox and everything for it, and the mechanism for the pitch thing. I know how it works. I'll show you guys how it works. It's really easy, super easy, totally easy. 3D printing will make that like not a problem. That means I am going to be making my own custom prop blades that will look very similar to his, but will be for the scale airfoil profile, and I'll put carbon rods through them for stability and whatnot. But the beautiful thing about resin printing is that you resin print your blade with a cavity for the hole for the rod. You dip the rod in the same resin that you printed the blade from. You slide it down there and you put it in your curing chamber with the rod in it, and then recure it with the rod in there, and it becomes a part of the fucking thing. It's amazing. I'm so excited to get this resin printer. So excited. So that means we're going to have... Let's work out what the spinner diameter is, because this is going to be important. This is going to determine what size limitations I have on the mechanical structure that actually does the pitching of the blades and like rotates the blade to pitch. So let's work this one out. We can go based on not that photo. We have another photo that will work well for it. I took a whole bunch of screenshots and I'm dragging them into this folder the whole time, and I must have taken a bunch of screenshots. Oh no, this is it here. I was going to use this one. This is a nice clear shot of the props and the wheels. So I know that the wheels are 35 inches in diameter, so half of that is 17.5. So using this image, we come back to here. Let's load in another image. And we're going to find it. Where are you? There you are. Drag it around like that. So over here where we have the circle for the tire, if I just drag you until that middle and the top are touching. Middle and the top. Close enough. Yeah. Let's drag you over here. Grab the circle and drag you back over to there. So a little bit over. That's okay. Then I can come in and go now I've drawn these lines on the props because it lets me see where the center point is. So I can cut through the center point to the other side. And get pretty close to what we've got. And if we pull a measurement off that, 60 mil. Now that's not bad. That's more than enough space to do something really interesting. Is that all? Oh shit. Okay, so the mechanism that holds the props, the blades and everything together and rotates them can be quite compact. I can do that inside 60 mil or a little bit bigger just as the cowling starts to widen out. So it is a push-pull mechanism that rotates these non-concentric hinges, like on here. So you've got the blade on its own axis. Let's go full face cam. You've got the blade on full axis like this. And there's an off-center thing that pushes and pulls it to rotate the blade angle attack. So that can be made quite compact, and it's a symmetrical design, so it's self-reinforcing with the other blades, and there's 4 of them. So that's just a slide bushing with your 4 linkages to the offset linkages on the blades that are on their own little bearings and in their own housing. And that pushes and pulls on that, so that the rest of the mechanism that starts to beef out and get bigger has to go around the motor and the planetary gears, so the planetary gearbox, and then there's going to be linkages that push and pull on that collet. It's doable. But to be on the safe side, I'm going to boost this up to 70 mils. So it's not quite going to be scale, but I'm doing something pretty awesome, so I think it's well worth that little bit of scale and accuracy. And if we look at 70 mils, it's not that much, it's only 10 mil difference, but now I have this much space to work with versus this much space to work with. it's a tiny difference, but it's all the difference. It will make all the difference. So we will say the spinner diameter. Let's grab a... It's a white one. Ooh, there's a bronzy color. Let's go with the bronze color. I don't need to draw it. I'll just write in here. Prop diameter, spinner. Diameter. It's going to be 70. Awesome. Right. What else do I need to work out? I think that covers it. Like, there's other stuff like the tail and whatnot, the tail assembly. But that again, that's going to be like either pull it off the balsa plans or find a decent photo and pull it off of that. Ooh, you know what we do need to get is this one. We need to get the horizontal stabilizer. I need to change this again. This one, yeah. The horizontal stabilizer. I keep forgetting that I changed the camera from full face to desktop. So let's come in here in this like collage of dimensionality. There we go. There's the catchphrase for the stream. Collage of dimensionality. Dimensional collage. It's got nothing to do with space or time. Well, it's got everything to do with space. Or more specifically, the size of space, because you can't just say space. You need to say how big is space. And now also, because you're dealing with gravity, I'm rambling. If you're dealing with gravity, gravity affects the density of space. So high gravitational zones or areas where with high mass or high velocity compresses or decompresses spatial dimensionality, which is how LIGO works, which is awesome. You just point a laser down a track in two different directions, the same laser, and depending on how the laser wibbles and wobbles on its phases, lets you tell if there's been a bit of spatial compression in one direction or not. So this is going to be tricky. I need to lay you over like so. And then make you same. Same close enough. Pretty dang close. And then like if we delete that one and we grab this wing cord. Ooh, okay. Oh wait, no, I'm doing this all ass backwards. Same this way. Alright, man, I'll see you later. I hope you enjoyed the stream. Thanks for stopping by. See you tomorrow. I'll be streaming again tomorrow. Like so. To the middle of the plane, to the end of the plane. let's do it off this back edge there. We got a nice clean line, and you got that camera mount that he put on the back top of the plane. You put a reversing camera on the fucking plane. How cool is that? There we go, sweet. And so now we can get a rough measurement of the back end. Like from here to here. And the number is 790. Ooh, that's interesting. It's very interesting. And we can drag this. Drag this, and we can put this. So now I pulled this measurement off the default wing. So like the original wing. So this is 250 wingspan OG. So this is the original span. So the wing chord. Where'd that pink fucking pen go? Yeah, that's OG. So the new measurement will be 280. 300? You're shitting me. And it's still under. $310. Holy crap. How big is the print bed on my printer? I need to go double check because that's cutting it damn close. Phenom. So this is the printer I want to get. And we have a print volume of 276 by 155. Now, I don't know about you, but if I draw a box, and we'll come in on that, so what is it, 276 by 55, so if we just go 270 by 150, and we measure from the one corner to the other corner, we only have 308. God damn. Damn. So we have to make it smaller. But wait. It's not the end of the world. It's not the end of the world because I'm measuring that with the leading edge slat. And this thing has flaps and ailerons the whole length, which means I only have to print the internal chord of the wing, and I can print the leading edge slat separately, and I can print the aileron separately. You're safe. It'll fit. Fucking barely. Oh my god. So all this business with the wing, I need to just scratch that out. That's bad. That's bad data. It's bad information. We need to get better better, 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 better. So now that I have that measurement, wing chord total, where's my pen? .310. This is one fat wing. I mean, 310 millimeters. There's a lot I can do with that kind of area. Right, so let us grab an image of the wing that he made. So I have this image, and I have probably go with this one because that one's at the very end of the wing. Right. So between these two, I should be able to work something out. And I'll draw a sketch of it on my book too, so I can notate the measurements I end up choosing. So this one I can flip it around. Nope. Properties. Flip it. Flip it. Flip it. There we go. And this needs to get smaller. Probably be heaps easier to do all of this sort of stuff in Photoshop, like lining up the images and things. But I can't be bothered opening up Photoshop. I'd say that's pretty damn close. Pretty damn close. And we had that just so happened to be lined up almost perfectly as well. So these two do need to be just a little bit smaller. Spot on. Yeah, okay, so that's lined up. So from there and a little bit past the back, because he did add a bit to the end on the back, so that lines up nicely. So we got the the hooked teardrop for the slat. And then almost a perfect circle for that leading edge. And it's 2 curves in that part. And it comes out like that a bit, and then straightens out. Grab my razor. Cool. And if I just make that a bit like this rather. So I'm not drawing off the end of the page. .310, which means I can now pull measurements off of this for, because we've got here the this would be the end of the wing, so aileron. So the chord for the aileron come off the come off the back there like that, just for reference. And then the chord for the aileron we will make 90. And the chord for the wing section itself from here to there, so 165. See here. Let's do the tail section like so. The elevator is 790 across. And the total, if I just draw a box, would be better. Just draw a straight line. From here to maximum leading edge is 200. Yeah, the pen's dying. It's a brand new pen. How interesting. There we go. $200mm, and the actual elevator cord, so the flappy bit, is going to be a little trickier to measure, because if we look at the imagery for it, where is a good one that shows it nicely? This one here will do. So in the core of it, it splits. So the very outside edge is a full 200mm of aileron cord. But I need to now work out what that's the length of that bit at the inside there and what this is, which we can kind of see in this picture. No, not that. We can close that. I've got my bed. What was it? 276 by 55, 155 by 400. I might have to print each wing section in 3 parts, which is alright. It lets me put spires in nicely instead of trying to push a wing spire all the way through a whole length of a wing. I can join them, and it's resin, so I just take a bit of the resin that I just printed it with, paint it on the edge, stick them together, and stick them under the UV lamp, and poof! Now it's one wing. Let's make this 167, and make this one 155, 267. There we go. Lovely. We can just about see this line here. Can't quite see where this edge is, but we can see the length of this inner part of the elevator, the stationary elevator surface. So if we go from the center point out to there, and then up to say if we go say 290, and then in by should we say half and half? Let's have a look, see what photos we've got. Make more of an estimated, an educated guess here. It's not quite half and half. The flat area is actually larger, even without the extension that he put on it. What other images did I grab? I know I've got some good ones somewhere. Aside from this one, this one looks at the underside. Aircon is too cold. Cold aircon is cold. I don't think I have a really good photo of that elevator. And this is no good as well for like getting that measurement like proper, because he's pitching up at the moment to keep his tail down when he's on the runway. And you can see there how you've got that little bit of a difference there in that step, with this edge that's pointing down from the camera, and then the other edge that's stationary, that's giving you this like discrepancy, where the flat edge is further out than the top edge of that one. Yeah. But that back edge is a definite line. So I measured from here to here and then plussed a bit. And we can get this measurement nicely. And what did we say it was? 290? $290, so that's 580. And then we'll just have to guesstimate how big we want the fixed area versus the flap area. I'd say maybe go like 1/3 fixed. What does this say? See, this has got it all ass backwards. This is the short, like the flap area is smaller than the fixed area. And it's got a fucking delta to it. Like it's swept. It's not, it's a fucking straight line. I'm looking at a bird's eye view of the plane here and it's a fucking straight line. There's no sweep angle on it. This is why I don't trust the balsa plans. Do not trust them. Does this edge line up with that edge? Like, is this actually sticking out further? Shouldn't be. Do I have no other images of this damn plane? So yeah, that doesn't line up. I think there's a step there. There is a step. So it is total at 200, and then that step would be like I wouldn't go as far as 180. 185? Yeah, 185. Still need to work out how far it comes in though. Which is going to be even harder now that we've determined that that is actually a step, not just the camera perspective of a sloped surface against a flat surface. That's a close-up of the tailing edge. So if we go from there, pivot point here. I just don't trust the balsa plans. When the guy that made the balsa plans made the balsa plans, he probably had, you know, access to the actual plane and pulled measurements off it with a tape measure and stuff, which would be the ideal situation. But then he's adjusted it for scale flying, so adjusted flat areas and stuff like that. You never know what they did when they made it, whether it's perfectly to scale or if it's adjusted for scale flying where you need slightly different surface areas. So there's no way to know, and that's why I've come in here and I'm working this out for myself. Yeah, I think this is the best image I've got to try and work it out with. And from here to here, let's use my hand. Let's do an Adam Savage. There, to there, and then it's off by that distance. It's 1, 2, almost a third. Let's make a number up. Let us make up a number by coming in here, picking a spot where it gets darkest in the picture, like right there. Come off of this line. And we will make the fixed area, screw it, let's just go 90. The fixed area is 90. And the rest of it is 110. So grab my pencil and let's just draw a cross-section sketch of the center of this. Not to scale, obviously. And we'll like do one this orange color and the other in the red color. There we go. Takes forever to get this pen warmed up. Oh, there's glitter in this orange. Goddamn glitter. Right. This section to this section. And use this pen. This section to this section. 90. And the other one is 110. But this part to this part. Now we said that was 185, so that would make it. My head is not working with math right now. There's too many numbers in my head. 185 minus 90, 95. Why was that so hard for me to work out? But that's not right. No, wait, that's right. It's 185. I don't know why I'm working anything out. That's just 185. Right. Elevator. Cord. Ta-da! Show you what I've been working on so far. It's a mess! Wow. It's so hard to see for you guys. There you go, a little bit closer. Getting all the measurements, angles, and stuff in. Working stuff out bit by bit. But I think we are getting close. We're getting very, very close to putting away the pens and pencils and paper and just get some geometry made. Get some geometry made. Put this one away. Run out of places to put my pens. Fantastic. Pack away the toys. Whoa, sorry about that. Rip headphone users. That's done. I'm going to put this up here. Let us make something. Let us just make something. What'll be the easiest thing to make? The quickest thing to make. Let's go home. New part. Now, let's keep with the tradition of the cyberbike, and we're going to start with the tires. Nice and boring. Oh, yes, 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 yes. Let's make the rubber tire. These are big, round, chunky boys, weren't they? Ooh, what thickness were they? We know what diameter they were. What thickness were they? Probably work that out pretty easily. Let's go back here. Don't think we brought that image in. Let's bring it in. Oh no, we do. Right there. We were working out the diameter of the that. So off of this is what I love about this kind of geometry, is because it's a really just round tire, we can half-ass it and say it was, you know, give a little bit for going inside of the rim. So we'd say like the rim was across here. Actually, let's figure out how big the rim was. So let's say 55 for the rim. Where did that 55 go? Whoa, what you doing out there, buddy? Come down here. There you go. And we can work out the diameter of that radius in the tire. Let's go a bit bigger. Chuck this in here. This will give us the cross-sectional profile of the tire, the rim. This one, so there, sweet. So you see that rim looks super narrow to me. I don't know about you, but that don't look right. But that's not in the right place either. Did that wrong. We want this one. Come from the middle to the outside of the diameter of the rim, and then out to where it meets the profile of the tire. That looks better. So that gives us a rim with a, what is that, the width of the rim of 30-ish something? 3 centimeter wide rim. Yeah, those would be pretty chunky. Let's actually go up to 35 and call it a day. So let's make some sketch constraints from the center point up and out. So we want it to be 35 wide by 50. Did we say 50? I think we said 50. We said 50, didn't we? 55. Lovely. Right, let's grab this circle out here again. So this is the limits of the rim. And you'll have a wall in here and a step down and whatnot. So are there sidewalls on this tire? Not really. It just the radius comes in and it goes straight to the step for the rim. So let's drag this chunky boy out. Let us put a point on the outside there. Let us set that point's distance. Delete that. Let's grab a line. Make the line a mirror plane. Now we can grab that point. Sweet. 177. Oh, I've done it again. Just camera of me talking to myself. Yeah, I'm doing this. I'm making the tires. So we've got a chunky rim there. And this is going to be the sectional profile of the tire. No, don't do that. Bad tire. You need to stay in the middle, boy. Let's just grab that shit and just go, you lot. Do not move. Ever. And let's stick you back in the middle. Lovely. Then we can grab you out to like so. Out to the point. We can trim Happy days, oh happy days. If we go back to that sketch constraint, we'll go with a slot to outer perimeter from just like anywhere to here. We'll give it a wall. We'll give it a decent wall thickness. 3 mils. That's a decent wall thickness. We'll grab this geometry, make it solid, and that one, please. And we'll switch to a different slot. Actually, we'll just take another circle. Like so. Nah, that's not gonna work. Trim, trim, trim. Trim. Get a mirror line. Get a mirror line going from the middle up. Sweet. You and you. Make yourself useful. Now this lip that we have on here, I want it to measure from here to here. 4 mils should do it. That point is left over. Then we can offset. $2mm thickness. Grab a circle, make a circle. Put the circle on the point, put the circle on the point. Trim the circle. Make it circularly constrained. Cool. And awesome. Ta-da! Tires. Just like that. Now, where's that picture? Let's close these. There's a nice close-up shot of one of the tires. I doubt there's going to be much detail on this one. Nope, because it's all moving. It's all blurry, blurry, blurry. There's some writing. I'm gonna. Oh, what do they call them? Alaskan tires? Yeah, Alaskan somethings. Yeah. There we go. One tire. Save. Tire. 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 What did they say the tires were? 177. What was that in inches? Five inches. 5, 6, 7. 7 inches. It's a 7-inch tire. That's not bad. I need to know what the name of those tires were now. Big Alaskan tires. Whoa, I might see a full sellout today. Holy balls. Stock price is up at 152. I mean, it's going to come back down to like 130, 140 again tomorrow. But I had a sell set for 155, but I cancelled it. I'm wondering if I should sell again. Yeah, that's a big movement. $555. I mean, this is all speculation. It could keep going up. It can go up to like 160. I'm just going to keep an eye on it. And then like tomorrow it can just keep going up more, but I doubt it. It'll swing back down. It's not going to float at these high numbers. Highly doubt it'll float at these high numbers. Stock prices are important because that's going to determine when I get my 3D printer. Right. Images. Scrappy. No, not Scrappy. Draco. Will go. Images. That's a screen grab of a doohickey. I doubt we'll pull a picture, like the name off of. Nope, I don't want to do that. That's bad. Do they get close-up shots of the tires? Nope, they got plenty of shots of Mike though, which is awesome. Let me just like tire. Ooh, that might be a good shot. No, it's only 600 by 600. I'm not going to get any further information off that. I really need to see if I can get a hold of Mike and just ask him some questions. It's going to be the best way, is to try and just get a hold of Mike and see if I can steal some of his time. See, making this is going to be fun. That's a nice high-res photo. What on earth is this? Abomination. Oh my god. Pilots, crazy people. I'm a pilot. I have flown an aircraft, an actual full-size aircraft. I have flown an aircraft once for like 30 minutes. So where's this picture that I clicked on? Where is it? Bad Google. View image. Bushwell. Bushwheel? Bushwheel. They're just called bush wheels. Righto. Yeah, close them. Cool. Tire. 7-inch bush wheel. Save. The file name is not valid because you don't like those things. Let's rename it the bush wheel tire. Sweet. And then come into plane, offset from origin YZ. Bring it out. We want the right side to the front, so back this side. Front. Doesn't have to be too far away, just like that. Sweet. Start sketch, new sketch. Sweet. Hide the sketch plane. Bye bye. Text, geometry text. First, I need a circle. Just any random circle. Geometry text on the circle. Push wheel. Can't see it. Too many E's. Push wheel. Let's go white. So I can see what I'm doing. Let's just put a space between each one. 2 space, 3 space there. Space, 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 space. And yes, everything looks good. Size. 8mm? No, a bit bigger. 14. There we go. And then we can adjust its position from the center, changing the diameter of this. 50mm from the center, so it's about right on the edge of the wheel. Click OK. We don't want to extrude, we want to emboss. Select the writing. We want it to be embossed from the face. 1mm. Wrap to face. Select face. Click OK. Edit other direction. Wrap to face just doesn't want to work sometimes. There we go. Bush wheel. I think 1mm is a bit thick. You can go 1/2 mil. It is a resin printer. So what I'll do is I'll make molds. I'll design molds for these wheels, and I'll resin print like a mold for it, and then I'll actually get some rubber silicone or something and cast rubber silicone wheels. We got 0.5. Yeah, we got 0.5. You gonna go ping again? No? Cool. Bush wheel. Cool. And do I want it on the other side? Nah. We have a wheel. Woo! Right. Should we make something else? Should we make the back tire? Let's make the back tire. Tail wheel. Now, he had, in the history of the Draco, he had 2 wheels. Well, he technically had 3. He had the original wheel, which was no good. It was bullshit. I think both me and Mike can agree on that. And then he went to the big one, which was an 18-inch wheel. 18-inch wheel for landing in sand and soft ground when he was out in the backcountry. And then later on, he switched to a 12-inch wheel, and he made a new attachment. So now I have to decide, do I want to go with the big 18-inch wheel or the 12-inch wheel? These are the questions. These are the big questions of life. I do wonder. How long have we been streaming for? 2 hours, 18 minutes. That's not bad. I think for a scale aircraft, the big 18-inch one will work better, because if you're landing it on grass or something, that'll do better. So we'll go with the 18-inch wheel. Okie dokie. Home. New part. Start sketch on the front face, please. Now this had a little bit of a different shape and size to it. So we know it's an 18-inch wheel, and we know it's wide, but we don't know how wide. Now if we go and we look at the pictures, let's see if I can spot the difference. This is the 18-inch wheel. And if I take its radius and lay it over on the side, it's about as wide as half as it is tall. So it is a half rectangle, which means if you take a cross section of its radius and width, it makes a square. Which makes life easy. We just go with that. And then if we look at the side profile, there's no sidewall, there's just this radius, and then it steps out a bit. I don't think, yeah, we might as well put that in. This looks like a drag tire of some sort. Is this off like a drag vehicle or a big go-kart? Pretty flat, a little bit of a radius to it. We'll put the radius in there because it tracks better in grass. Yeah. Let's go. So it's a square. Nice and easy. Let's start by getting our sketch constraints in. We need our central geometry for the revolve. I'm really lazy, so I'm only gonna do a quarter of the work. So we need one that goes, excuse me, up. Then we can turn those off, right. And then we need an arc that just does a thing. Then we need another arc that does another thing. But it needs to be circular coincidence constraint to that. What is that called? Tangent. Tangent. That's the word I've been looking for all of these episodes. I keep just calling it a circular constraint. It's a tangent. It is a circular constraint of some kind. Then there's a little bit of a lip thing. Like so. And then the rest of this, then tangent. Lovely. We're going to set the height to, so it's 18 inches, full scale, divided by 5. Should be able to work that out. 3.6 is the scale size in inches. And then we want the radius, which is 1.8. 8 inches. You not doing this anymore? Do I have the wrong thing there? It's not a full stop. It's a full stop. Inch. Let me just type inch. 1.8 inches. There we go. Which turns out to be 45. So we will reselect that and just type in 45. A little bit shorter, but hey, hey ho. Let's go. Extend this one. The music just so bad. I started playing this like ages ago and it just stopped. Let's put some music back on. Let's get to work. Sweet. Now we know that it's 45 and we want our maximum doohickey, which will be this one. No, let's actually do it off of this central point to that curve. 45. And we can say we need a perpendicular constraint from this curve to that edge. Holy moly moly moly. And of course, thanks inventor. Because reasons, I don't know. Screw you. Let's see if I can fix it. No, I'm not gonna bother. Sticky there, so you behave. Then I'll select you, delete that, delete this one. Right, let's try that again. I'm not going to bother with that weird curvy curve thing. So we'll bring one that comes down like so. We'll put our tangent in here. Already there. We'll bring you up. Grab another one. Now, select you. Stick you on there. Sweet. Sketch constraint from here to there. Make it so. Lovely. And where's that picture? Go with this one. This is the shorter one. This is not the 18, this is the 12. And I can tell because he's got this new King off-road shock in it. And this was the mod that he did after he made this new bracket for the new wheel. Pretty sure. Could be wrong, but pretty sure. Where was that picture? This one. And looking at the size of his forearm there and to the size of this tire, a man's forearm is generally 12 inches. If they've got a size 6 shoe, they've got a 12-inch forearm. So I would safely bet that that is the 12-inch tire on there and not the 18, because the 18 would be much bigger than this. See, there's the old shock that he had on there. So that was for the 18-inch shock. You can see the difference. This is the 18-inch tire. This rim, I'd say, is a third of the radius of the tire. Radius of the rim is a third of the radius of the tire. Sweet. So it's 45, a third of a 45. Divided by 3, 15. Really? Wow, I couldn't work that out. I need coffee. So 30. And I want to see if I can keep... Wait, no you don't. This, like this. keep this curve like so. What is it doing? Where did that come from? Did it just magically grow a curve off the backside of this? It did. Why aren't you constrained to that? You silly Billy. Right. You need a perpendicular constraint to that. Yes, thank you. This line. Okay, now I can... Where did your... What? Where is your central point? How did you end up there? Let's see if I can grab it. Point. Point 2. Curve. Curve. Point 2. No, I don't want point 1. I want... Alright, screw it. Die. From here to here. We'll just make it like that for now. Cool. Sweet. Now I can tell this to do that. Set a measurement. 85. $40. Sweet. Now we can run the tangent off of this to that. If it'll let me. You know what, we'll just leave it like that. Right, so this tire, sorry, the rim. How big we want to make the rim? So, 60 sounds good. By... Let's go 40. That's gonna look weird. That is gonna look weird. Is it? Is it though? I think it might just look right. Might just look right. Let's actually crank this down to 55. Give the tire a bit more chunkiness to it. Yeah. So now the music plays uninterrupted. Jesus. What a pain in the butt. Where's my slot tool? Edge slot. 3. Get a haircut. Trim, trim, trimity, trim, trim, chiroo. Grab the point, make it go away. Apparently I can't delete that point. Okay. A circle from here to here. Three. Lovely. This, offset. Three. What the hell? They don't do 3? They don't want to do 3. Weird. So weird. Offset. 3. See how it does it and then it dies. Offset. Let's do 2. No, it doesn't want to do 2 either. That is so weird. You know what it is? It's this circle. Let me delete that circle. One without dimension. Let's just drag one out and stick it. No, it doesn't want to do it. What the hell is going on? Alright, this tire, it doesn't get to be hollow. It's just gonna be solid. For the strangest reasons I cannot fathom. There's sketch. Actually, we didn't need to make that line. There we go. Mirror line. What are we going to call this tire? It's a good question. Can't read anything on the back of it, so we just call it the rear tire. Let's call it the rear tire. Whoa, caps lock's on again. Rear tire. Awesome. We have 2 tires. That is a successful day's work. We made 2 tires. Oh, I'm going to take a break. I've been streaming for only 3.5 hours. 2.5 hours. 2 hours, 30 minutes. Do we have anybody still in chat? Anybody who's still watching? Say hi. Say bye. We're going to call it there for the day. We've got lots of measurements and stuff worked out. I need to get the video edited and ready to send out. So I've got to do some more video recording for today's episode. Well, it won't be today's episode, but probably tomorrow's episode. Get an episode out tomorrow. It'll be the first episode of this series. It'll be very enjoyable, very interesting, and I hope you guys will be here tomorrow. I'll see you guys tomorrow. See you around. Ta-ta.